Okay. Well, welcome back. So this series is a set of videos where we're implementing what I'm calling a parasitic C compiler. It is a compiler written in C which compiles C and outputs C. And the goal is to make a self-hosted compiler. And it's going to be very simple because initially because the compiler is written in C, and if it can compile C, then it can compile itself. And once we have a compiler that can compile itself, then we can begin changing the language that it compiles to have a self-hosted language that is its own distinct thing from C, because C is not the most fun language to program in. So we're very close to having a self-hosted compiler, and hopefully tonight we're going to be able to bootstrap it. So currently, what I have is a compiler that, or really, it's largely just a lexer and a parser and a method for printing the syntax tree. So let me show you currently what I can parse. So I have this test program, and actually we can parse more than this. It should be like, if you go to, I have a whole bunch of tests that show exactly what I can parse. But I'm going to run the compiler. Whoa. I'm going to run, we're going to compile the compiler with clang, and then we're running parasic.exe on test.hello-world.parasic. So that's this file here. And if I run that, it does, it can parse everything, and it builds a syntax tree, and then it prints it out to the standard out. So there's a couple of limitations with this. Actually, a lot of limitations. So it requires that you use these macros around your function declarations. This fn macro. That's because I didn't want to parse the way that you usually define functions in C. So I added this sort of dummy macro. If we look at the definition here, it literally just spits out what you put in. So C understands this. So the C compiler understands it, and the compiler that I'm creating also understands it. So my compiler can compile a very specific subset of C to C. All right, so that's one limitation. You have to use these weird macros every time you define a function, or if you define a function declaration. If you do a function declaration, you got to wrap it in that. And if you define a global, you need to wrap the global declaration, or the global type and name in global. Those are some limitations. Another limitation is I can't parse, or I refuse to parse macro definitions, because it's a whole can of worms. And technically, I should be defining this standard C lib extension 1 macro in order to get fprintf s, the underscore s. This it's like a safer version of fprintf, and fopen s. These are functions that are not guaranteed to be in stdio.h unless you define this thing ahead of including stdio.h. And unfortunately, I can't parse this. So we're going to just comment this out and not worry about it for right now. Because I've found through testing, well, I guess I should test it right now. Let's make sure that this still works. I might get a warning. No, okay, that still works. So, and it is using fprintf s and fopen underscore s. All right, so we'll come back to this. That's sort of a to-do. In fact, to-do, figure out a way to set, what are these called? Compiler flags like this. I don't even know what these are called. So we'll figure out how to do that once we have it bootstrapped. But right now it's pretty not portable, or it's not as portable as it could be. All right. So this is effectively paracc.c. This is effectively the main function, or the main compiler source file. So we have function main up here, and we accept some arguments. We expect you to provide a file name in argv1. We open that file, and then we create a string buffer. This is my probably insecure string implementation. And we read the file to the buffer, and there's some panicking or it'll exit the program if there's an error. And then there's some logging here, but that actually doesn't work unless you flip a switch. And then we create the lexer. We attempt to parse a translation unit. So that is essentially one file. Actually, that's not technically correct. This really should be parse one file. But whatever, I'm calling it a translation unit. And then we display it to standard out. Okay, so the first thing that I want to do is I want to change up how this works. Oh, I should mention that one thing we need to support is, okay, ordering. So first thing I'd like to do is I'd like to rename all of my header files to something with a specific file extension to indicate that they are in this new language that I'm defining. So, and I'd like to do this through get. So how do I have get here? Yes, okay. So what I'd like to do is say get move parse.h to parse.h.parac. That's the extension I'm using for parasitic C. Is that going to work? Yes. Okay. And then how does that appear here? Staged changes. Okay, good. So let's do that for the other files. So not just parse, but we want to do it for lex. And we want to do it for cster buff, where we define C strings. Buff. They're effectively like standard string in C++, or like capital S string in Rust, except that they're null terminated. Move that to that. And then finally we want to change the main program, which is called paracc, the compiler, from .c paracc to .c.parac. Okay, so we've updated those. Rename parac files with .parac extension. And then we should commit this change here where we remove comment out the compiler flag for now. Okay, we'll push those. Now these are all gone, so I need to, that'd be nice if VS Code could figure that out. So we're going to go back to the compiler. I'm going to switch this to C. And then we need to update these. So h.parac. cster.h.parasy. Yeah, and IntelliSense is having a big problem with this. Include parse.h.parasy. That's correct, right? Parse.h.parasy. This is going to be lex.h.parasy. And this is also C code. And lex.h, does that rely on anything? No. But csterbuff, does this rely on anything? No. Okay. All right. So I think we're now ready. There we go. I think we're now ready to update includes with file name changes. Okay. All right. So what I need to do is anytime as we're parsing, or maybe after we're parsing, anytime we encounter an include that has a file extension that ends in .parasy, we need to treat that specially. So essentially we need to go in, parse that file, and create a .h file. The compilation stage of this compiler is it outputs C code into a .h file or a .c file, depending on how the file name is named. So in this case, we will compile this to csterbuff.h, and it'll be C code. Okay. So let's create a function. Right above main, function void, and I want to call this compile file. And I think we're going to have a recursive call in here. Okay. And we want to accept a file name, I suppose. File name, which is a character pointer. Okay. So we can copy over a lot of this stuff. Let's copy over all of this. I do need to copy this over as well. Delete, paste, argv1, this is no longer what it's called, it's now called file name. And down here, we will just call compile file with argv arrow 1. Okay. I kind of don't like a lot of this logging stuff, but I don't know. Maybe we can just separate it out a little bit. Yeah, that's a little more readable. Okay, so first we open the file. Then we create a buffer. We read the file into the buffer. This is all conditionally compiled based on this global up here, whether or not we want logging. So effectively all of this is skipped. And then we do lexing, we parse a single file, and then we output to standard out, but I'd actually like this to output to a new file. So here's where things are going to change. File pointer out. We're going to say something very similar to up here. and maybe we'll even log. Opening output file. So instead of file name, we need new file name. Instead of read, we need write. Instead of f, we're going to use out. So fopen_s takes essentially a mutable reference to some existing file pointer, and then this is an out parameter, so it sets the file pointer there. Okay, so we need a new file name. Const character pointer. Maybe I should hard code this for now, for simplicity. Parasitic.c. What we need to do is chop off the .parasitic at the end of file name. So that is probably going to require its own function. Chop parasitic extension, or just remove parasitic extension. And it's going to return character pointer, and it needs to accept a character pointer. File name. Okay, so I've done a little bit of research ahead of time. So let's write an example here. So if we have parse.h.parasitic, this should be transformed into parse.h. All right. So I know how to extract the file extension. What I would like to do is split on the file extension and then take everything before the file extension. Maybe I should look this up and just steal some code off of Stack Overflow. So I already intend to steal some code. This is how to get a file extension, everything after the dot, and we're going to be needing that later. Can I duplicate this tab and then go C, file name without extension? How do we get the name of the current executable in C#? File name without extension terminology. What is the terminology? JavaScript, split a file name. How do I should just Google this. How to remove extension from file name. Try this. This is probably a better version. A more general purpose solution to this problem could be this. Remove. And it does look like we're going to need to allocate some memory and do stir copy, stir rchar, and then ret stir. What is this? Okay, essentially they're using stir rchar, which is you find this character in this string, and it returns you, let's go here and search for stir rchar. This is in the C language. Okay, finds the last occurrence of the character. And this is an integer, but it converts it to a character in a null terminated byte string. Base name. Oh, interesting. This is exactly the problem that I was looking for, isn't it? Not quite. It's almost the same. They're looking for everything after the last slash. Okay. Pointer to the last slash. Okay. This is in string.h. So let's include string.h. String.h for stir archer. All right. So we need to search for the last dot, and then we need to check to see if everything after that is .parasi. Okay. Stir archer. Okay, give it a string, file name, and give it the character we're looking for, dot, find me the last dot, and it returns a character pointer. Whoa. It returns a pointer to the found character in the string, or a null pointer. Okay. So if you can't find a dot, that's a problem. If you can't find a dot, then could not find fprintf to standard error, could not, maybe we'll say %s is not a .parasi file. /n file name, and then exit with 1. Okay. Otherwise, this points to the last dot in the file name. This points to the last dot in the file name. So let's call this last dot. Okay. So everything after the last dot is the file extension. So what we need to do now is we need to do stir cmp. And do I want to use the safer version? Probably not. I'll put it to do. Use stir n cmp for safety. How do you spell safety? That's a bad sign. Okay. So how does stir compare work? We need 2 strings. And I want to say, are they equal? So last dot. This is really like the extension, right? Extension. and another string, which is going to be .parasy. And we're going to say if this is equal to 0, so stir compare, let me check the reference, stir compare returns a negative value if it's less than 0 if they're equal. That's the important one. Okay, so if they're equal, it returns 0. If they're equal, then we need the length of the string. Let's say if they're not equal. If they're not equal, we'll throw an error message. So is not a parasy. Well, yeah, exact same. Okay. So now we're going to say, what is the length of the extension? Strlen. What is this? The length of the extension. Extension. Int extlen. Strlen. Length. There's also a safe version, which I ought to be using, so let's add a note. I just like to keep moving here, so we'll come back to this. To do use strlen _s. Okay, the return value is for number 1 is the length of the null terminated string. Oh, right, yeah. Okay, so there's no error conditions. Okay. Next, we need to copy everything in file name. So I guess we need the length of the file name. Int file name length equals strlen file name, and exact same to do here. And then I want to do stir cpy. And to do use stir n cpy. Stir copy. Okay. Destination and source. Destination. Actually, I do think I want the size, destination size. So I'm going to have some like allocated string, right? So I guess I should do that first. Character pointer, new file name, equals malloc, file name length minus extension length. And then we need to copy stir n cpy s. Oh, that's stir copy. Okay, I actually do want stir n copy. Stir n copy and stir n copy s. Copies at most count characters of the character array pointed to by source. That's what I want. Okay. Copies at most count characters. Okay. So first I need the destination buffer, which is going to be new file name. Next I need the size of the output buffer, which is this. I'm not sure how this deals with the null byte at the very end. Next I need the source buffer, which is file name. And then how many bytes do I want to copy over? I want to copy this many. Whoa. I want to copy this many bytes over. And could I break this up? Does this return an error code? Returns a copy of the destination. Or, oh, okay, and actually the one I'm using is this one, stirring copy S. Returns 0 on success, returns non-zero on error. Okay. So I don't know. If this is not equal to 0, then p error could not copy, could not stir cpy new file name. Exit with 1. Okay. Okay, and then all we need to do is return new file name. Let's test this out. So we're going to comment out this, and we're going to do remove Parasitic extension from parse.h.parase, and this will give us character pointer new file name, printf /n new file name. All right. Oops. Okay. Doing something with get. Did I just mess something up? No, I don't think so. Okay, I need to change this. Parasitic.parase. And then I just want to, doesn't really matter if I don't pass any args in, I think. Okay, unknown file type. It doesn't like this. Parasitic. It doesn't like the file type. Do I have GCC installed? CL, oh god. So do I have to stop using Zig? Zig cc para cc dot c dot parase. Yeah, it doesn't like that file type. LLD link. Could I say output it as paracc.exe? Still doesn't like that. Okay, so maybe I need to change my approach rename these to Parasitic.c and Parasitic.h. Okay. That's unfortunate, but I can do that. So where are my get moves? Parasitic.c. And then these are all going to be .h. Lex. .h. Lex.h.parasi, right? That's what it's currently called, yeah. And parse. And cster buff. Cster buff. And that's it. Okay. So now I do need to change this up. So the code is not really going to work. Well, this should still work. This test should still work. So let's try running it. The file no longer exists. .c. File not found. Yeah, okay. So now I need to rename these. .h and .h, and we need to go in here and change this to .h. Don't save? What did I just do? Yeah. .h. That was in the wrong file. .h. Okay. And then /this. Alright, we're getting buffer too small. Nice. So I think this is from the _s functions. They do some bounds checking for you. So that's actually pretty nice. I just got an exception instead of a buffer overflow or whatever it's called. So my guess is that if I add one more thing there, then I'll have a buffer that's big enough. Yes. Okay. Yeah, so that worked. All right. I do need to change how we're doing this now, though, because I need to remove. I need to go from this to this, because that's how we're naming it. So first, we search for this, and then we gotta do it again. .c or stir cmp extension. So at this point, we have like this full extension. It's not equal to dot para c dot h, and that's not equal to 0. If either of those conditions are false, then do this. It is not a para c dot star file. Okay. So now the length of the extension is this, and this is either that or that. In fact, we know the extension's length. So the extension length is, 1, 2, 3, 4, 5, 6, 7, 8 with a null character. So why don't we just say dot para c dot star here. That's the extension length. We want to the entire file name's length is this. We need to allocate enough space for the and let's do para c length equals stir length. This could be like pre-computed, but whatever. Dot para c. Is that gonna give us a null byte? This is confusing. Undo. We'll just say -1. Para c slice length. Para c slice length. So we just want to remove these characters. In fact, if I just say this, let's play it safe. We want to remove those characters. All right. Geez, this is like harder than actual parsing. So I don't need that. We need a buffer that has removed para c slice length. And the last two characters. I feel like I should be using sprintf. Sprintf. snprintf. snprintfs. All right, 8. snprintfs. This is in stdio.h. Okay. Some errors are detected at runtime. Okay, let's try this. SN printf underscore s. What, is that what it's called? SN printf underscore s. Alright, let's copy this over. Alright, so we need the buffer that we're going to write into, which is new file name. The buffer size, which is int buff size is yank this. Buff size. The format string, which is going to be, first we want the everything up to the last non-dot. Oh boy. Then we want either .c or .h. And we need file name. Does this work if I do .star inside of here and then I specify how much of the file name I want? I think it should. So I just learned that format .star. Is that the only case? Okay. If you use .star s, %.star s, then you provide the string and then you provide the length. Or is it the length and then the string? I think it might be the length and then the string. And in that way you can sort of slice the string. Ooh. Alright. So file name and then, and I think the length comes first. So in this case, they want 4 characters from this string, and then some number of characters from this string, and it's going to be that. Yeah, so the length comes first. Okay, so the length comes first. How many characters of this do we want? We want file name length minus Parasitic slice length plus, actually, yeah, just that. Yeah, just that. Okay. And does this return an error? Let's see. Does SN printf return an error? It returns an int, 8. Return value 8, the number of characters, not including the null terminating null character, which would have been written to buffer if buff size was ignored, or a negative value if there's a runtime constraint. Okay, so we want to say if this is less than 0, then we will could not make new file name, and we'll say this. All right, let's try this out. And we need to update our test. And this is always going to give us, okay, so why don't we say %c, some character, and we will say buff size ext C or H. And we'll give it a character C or H. I could use a ternary operator, but I don't know how to parse them, so we'll just do if it ends in, if file name ends with a .c. Ugh. File name file name length -1 equals C, then C or H equals C. Else if it equals H, then equals H, else to do. Error reporting. Alright, so the to-do macro throws an error if we ever get here. Okay. So if we test it with this, will it work? Compile. And undefined symbol sn printfs. Uh-oh. Sn printfs. So I think we probably do need this defined at this point. Sn printfs is invalid in C99. Oh, okay. Dash standard equals C11. Will that work? Sn printfs is invalid in C99. What is going on? Sn printfs. Available, and if the user defines this. This is defined by the implementation. That's stdio.h. And if you do this, you define that to the integer constant 1 before including stdio.h. Well, I'm doing that. It's invalid in C99. Since C11, I mean, yeah, that makes sense. sprintf. Okay, should I be using sn printf? Should I just use sn printf? Let's do that. So I do not want to have to do this. Let's go down here and we'll use the unsafe version and we'll leave a comment to do use sn printf s. Alright, will you compile now? Yes, it compiles. Let's run it. Okay, we're getting an error here. Is not a pair.c star file. So that could be either of these. Doesn't have a file extension. Which one of these are we hitting? Compile and run. We are hitting this one. Stir compare. Okay. The extension equals this or this. Then print that. Let's printf. %s, new line, extension. we're getting .h. Interesting. Oh yeah, okay, that makes sense, because we're asking for the last character in here. Okay, so I guess we just want to find the first character. And then maybe we get rid of this and this. Let's try this. Compile and run. Okay, we are getting .parac.h, .parac.c.parac.h, and we're saying this is not a .parac.star file. Okay, so something's up here. Stir compare is incorrect. Foo.parac.h is not a, and this is the extension. Okay, if these, yeah, if this is not equal to 0, so that means they're not equal. If it's equal to 0, then that means it is equal. Okay, maybe let's rewrite this. Am I going crazy? If it's not the case that either this is equal to 0, or that's the problem, or this is equal to 0, then go in here. Ugh. Recompile. What was my little shortcut? This semicolon. Okay, so if I do this semicolon, if $, and then do /paracc.exe. Okay. We almost have it. Foo.pa. Very close. First of all, let's get rid of these. And try it like this, and then we'll think through it. Foo dot we can remove this print. Geez, we're an hour in and I've only done file extension parsing. Ugh. I think we need one extra space in the buffer. Foo.p okay, how much of file name do we want? We want the file name length minus this length minus 2, because we do not want, all right, we want to get rid of the extension, right? ext length dot star. So that's how much we want to remove. ext length. We want an extra for the null byte, and we need 2 extra for the new file extension. Ugh. That's the buffer size. So we just want the file name with no dot, and we want the extension, we want to get rid of the extension length, the length of the extension. Okay. And then we're going to add a dot, and we're going to add either a C or an H. Let's try it. foo.h. All right. We got it working. And let's test it with .c. And what do you know? It works. All right. Remove Parasitic extension. Okay. So we've now got a functioning file renamer. Ugh. All right. Next, in compile file, we're going to say the new file name is remove Parasitic extension of the file name. I'm not worrying about freeing. I have not used the free function at all in this program. We're just allocating memory as much as we want, and we're not going to worry about it. Maybe I'll optimize that later, but also maybe not. So this is an allocated string, and I should call free on it eventually, but I'm not going to. Okay, opening output file. We are opening this output file in write mode, and then we are going to write the translation unit, the AST, to that file. Okay. All right. So let's see if this works. So currently, with nothing up my sleeves, I do not have. All right. So I should rename this to. I guess I should use git move tests this thing to tests this thing .c. Okay, we added that file extension. Next, we're going to call this. We're going to compile our compiler. And pass it /tests this file. It should create a new file called helloworld.c. Let's see. Okay, this is not a .parc.star file. All right, why not? Ah, I see, because there's a dot at the very beginning. Okay. Oh boy. Can I just do this? Would that work? Hey, it worked. All right, cool. So, yeah. I guess if I auto format this, it's not gonna auto format. All right, cool. So this is effectively a quote-unquote compiled file. We've compiled our first program. All right, pretty neat. So there's a problem. I need to, let's write a to-do up here. To-do bug dot slash thing dot para c dot h doesn't work because of leading dot. All right, so that's a bug. All right, we've not really done any compilation. Can I roll this up? Yeah. You don't need the logging. You don't need usage. All right. So we have compile file. Let's commit this while we're at it. Oh, and I think in my git ignore, how do I distinguish between? Because I don't want to commit these. These move to the recycle bin. Okay, source control. We're gonna do all of this, and we're saying implement file renaming in compiler. All right, let's push those up. So we open a file. To compile a file, you open a file. Next, you make a buffer. You read the file into the buffer. This, nothing actually happens unless you're in a logging mode. Next, you create a lexer and parse a translation unit, which actually is incorrect terminology. This is just parse a single file. Then we remove the file extension. We change the file extension with that new function we just wrote. We open a new file with that new file name, and then we write the AST to the new file. Okay. I think what we should do here is we should return a list. So my idea is, what just happened? Undo that. My idea is that we will have some kind of struct I don't know, called compiler, which is going to have a struct list called, I can't call it to do, Q? Oh boy, do I need like a pop first or push first method? Oh, that's not too hard. Honestly, it doesn't matter what order I do it in. Okay, let's say scene processed files. So this is going to be a list of I'll explain what list is in a second. Character pointers. If we can I go to definition? Yes. So I have this structure called list. It holds list nodes, a first and last pointer, and internally it has void pointers to the data. So I can't. I'd like to have this be the right type, but we just store void pointers to the data. So anything that you put in a list, you have to remember what type it was when it went into the list, so that you can pull it out later. I think this is kind of just how Java programmers worked with like linked lists and array lists and all that, like before they had generics. You just sort of like cast stuff in and out of the lists. I don't like it, but so list node, this is just a linked list, and so I always document in the struct what the list is containing. So this is going to contain character pointers to file names. Okay. And then to be processed. And this is the exact same. Files to be processed. All right, so we're going to keep track of every time we come across an include that ends in .parasi.something, I will save this file name in one of those. I'll save it in, well, first I will check to see if it is in this list. If it's not in that list, then I'm going to throw it in this list. And then somewhere there's going to be a loop that's going to be continuing to process files in this list. And when it does process them, it puts them in this list. Okay. Okay. Function compile project, maybe? Or maybe this could just be recursive in here. So maybe you just pass in a struct compiler by reference compiler. And then down here, we will need to create a compiler. Struct compiler. And I forget how C initializes stuff, so I'm paranoid and I just initialize stuff. Compiler dot fields to be processed equals list init. So this just zeroes out those things. And processed files is also an empty list. Okay. I could be wrong about that, but whatever. I'll fix it later if there's a better way to do that. So now I just need to pass in the compiler by reference. So you pass in to the, when you call this function, this compiler function, you pass in the root, the file that contains your main function, and then it's going to sort of search out all the other files that it needs and sort of do like a search. Yeah, it'll search for them and compile those as needed. Okay, so this is compiling one file. Maybe I should have let's make another function. Okay, void compile project. In which case, I actually don't need the compiler up here. Paste that here. And I just need a file name, char pointer, file name. And then down here, we actually want to say compile project. Okay. So we've got a compiler and root file name. Project root. Okay. So first thing we're going to do is we're going to say compiler dot files to be processed. Oh, thank you, it. Oh, that's nice. It put the arrow in. I'm going to say list push project root cast to a void pointer. What's the problem? Argument is right, I need to pass it a reference to the list. Okay. Now we're going to go into a loop. While compiler arrow compiler arrow files to be processed is not empty is not equal to null. So I'm gonna need like a push and a pop, or I need like a pop function. Okay, that's not too hard. So here's our loop. We need a character pointer file name equals compiler files to be processed. We're going to say list list pop front. I think we can actually do this pretty efficiently since it's a linked list. It has a pointer to the first and the last. So pop front, and I need to pass this by reference. This function does not exist. List pop front. And we're going to need to cast this to a character pointer. It's going to give us a void pointer. List pop front. Now we're going to go back to the parser. List push. We're going to add a function. List pop front. Take in a struct list pointer. And the return value will be void pointer. Extra parenthesis. Okay, list arrow first. Arrow data is what we need to return. So let's say void pointer data equals this. Then we're going to say, oh, and we should do a null check. We should say, in fact, why don't we say function boolean is list is empty with a struct list pointer. We'll just say return list arrow first equals the null pointer. Okay, so we need to check if list is empty, then return null. I don't know. And then otherwise, we save the data. We're going to return the data at the very end. Data. And before that, we need to mutate list arrow first equals list arrow first arrow next. So point list to the next node. And I mean, this is really a place for free to do free the node we just popped. The list node we just popped. Pop front. Okay, I think that's it. All right, so we pop list pop front. So this is like a queue. We're pushing to the end of the list and we're popping from the front. I guess one extra thing we should check is if list arrow first equals null at this point, then we need to set the last list arrow last equals null as well. That's something we should check. Okay. So we've got a file name. So now we just say compile file name. And then we're going to add this list to All right, and we could get struct list new files. We could get a list out of this, and we need to first list push into compiler arrow files to be into processed files. We need to push the file name. This needs to be a reference, and then struct list node pointer node equals new files arrow first. We're going to iterate over. Yeah, so all right, we're not actually returning a list here, but that's okay. Let's quickly struct list, return a list, return new files. I'm not sure what to call this, but struct list new files equals list init. This is just dot, and then we do a while loop over the node. While the node is not null, node equals node arrow next at the bottom of the loop, and we say list push into ref compiler arrow files to be processed. We want to push node new file char pointer new file equals node arrow data, and cast it as a character pointer new file, and this should be cast to a void pointer, and then move on to the next one. All right, anything else we need to do at this point? I guess we should log. We're doing a lot of logging. I would like to get rid of this logging. It's not super helpful. So we print out the entire file, and then we print out all the tokens in the file. Not super helpful. I'm going to comment that out for now. And I think this almost works. So the one thing that we're not doing is we're not adding to this new files list. So compile file needs to return a list of all of the .parasi.something files that it encounters in include statements. All right. So I think what we should do is make a new function. Void, we will accept. Well, honestly, we could just return the list from there. Struct list. Find new files. All mentioned Parasi file names. All included. Maybe we'll say that. Included Parasi file names. We're going to accept. We need to accept the result of parsing, which is a list. It's a list of items that we parsed. So where was I? We need to accept a struct list of items. This is actually, we should accept it by reference, and this is going to be translation unit. All right, that could probably use like a type def. Why do I have this open? All right, so we've got a list of items, so we've got to iterate over them. List node pointer node equals translation unit arrow first. This is how you iterate over a linked list. And then we say while node is not null, node equals node arrow next at the bottom of the loop. And I'm going to pull this up here. We're going to make the new Parasitic files up here. All included file names. Parasitic file names, listed it, and at the bottom we're going to return Parasitic file names. And then down here, we are just going to return all included file names from the translation unit. Okay. Here we need to say item pointer, struct item pointer, item equals cast it to a struct item pointer from the node's data. So it's just a list of items. So let's extract the item. Now we need to switch on the item type. So switch on item arrow tag. All right. If it is a item pound include, if it's an item pound include, then we need to see if the extension is .parasitic. All right, so I guess I should have like a separate function. If that's the case, then item we can view it as a pound include, and get the file name. We will say file name, character pointer, file name, switch case, okay, yeah, and we want a default, which is just nothing. How do I say nothing? This is not a valid, I guess I can just do this. And all right, right now we need to say, yeah, so get the file name, and then if file name, we want to say is Parasitic file, then we need to list push into Parasitic file names by reference the file name as void pointer. Okay, now we just need to write this function, and then I think we're actually done. Okay, so this returns a boolean, is Parasitic file, given a character pointer file name. Is there a way to see string suffix, like ends with? That's essentially the function I want to do. I want to make sure my string ends with .foo. Well, what do you know? This is very similar to what we're doing. Ends with strlen, stir compare, and they're doing some slicing. I mean, honestly, I just want to copy this over. We will credit this person. Function bool ends with function from here, thank you very much, to plinth on Stack Overflow. So we're checking that neither the string nor the suffix are null. That makes sense. And I'm going to return false here. And false here. Am I including standard bool? I don't think I am. Pound include standard bool. True, false. The length of the string is this, the length of the suffix is that. If the suffix is longer than the string, then you can return false. And then we're going to do stir and compare. So this is essentially slicing the string. String, go to the length of the string minus the length of the suffix. Okay, that makes sense. And then compare it to the suffix. And this is the length of the suffix. And if it's equal to 0, then we have a match. Okay. That makes sense. I trust that code. Size t. Ooh, okay. So size t I cannot compile, so this needs to be changed to an int. To do, change these back to size t. So here, all we have to say is return ends with file name .parasi.c or ends with file name .parasi.h. Okay. Is Parasi file. Okay. So let's make a test. We're going to do pound include. We're going to say hello world, goodbye world .parasi.h, and then we're going to create a new file called goodbye world.parasi.h, and this is going to have a function called void goodbye printf goodbye. We need to include stdio.h. Should I include cheats as well? I'm not sure. Probably not a bad idea. Okay, hello world, and then we're going to print, we're going to call goodbye. All right. I'm seeing one other problem. So in the syntax tree, we have a we're going to have a problem. So we need to rename all of these files, since the compiler takes in a .para.c file and outputs a .c file. So in this case, with this file, goodbyeworld.parac.h, we're including it here, but then we need to actually include the .h file, goodbyeworld.h, not this. So for each of these is Parac file, we need to mutate. We need to call remove Parac extension on the file name, char pointer new file name. Then we need to say item as #include dot file name equals new file name. So we're mutating it. And this is another place where we need to freeze the old string, but I'll worry about that later. Okay. And then in compile file, we actually need to do this before we display it to the output file. So struct list included Parac files equals this. Included Parac files. And I think we should probably do this right after we parse it. Okay, so first we parse it, then we look at all of the included file names, and this also changes, this mutates the AST. It's going to mutate the AST by changing essentially goodbyeworld.parac.h to #include goodbyeworld.h. Okay. And then we open a new file and we output the AST. Finally, we return the included Parac files that we still need to check. And nowhere am I checking if there's like circular imports. So that's another thing we should think about. I think this is good enough to test at this point though. So let me do to do don't recompile already compiled files. All right, so that's the next thing we're going to do, but I want to test it right now. Okay. We've got some errors. Initializing a struct list. Compile file. It does return a struct list. What? Compile the file. Compile project. A list of new files. Implicit declaration of function compile file. Okay, maybe this is the problem. Where? It's being used here, compile file. So compile project should be below compile file, I guess. Compile file. Let's see if that solves the problem. Okay, label at the end of a compound statement expected a statement. So this is in our default case. Where is default? Right here, I guess. I can just click on this. All right, I'd like to do this. If I remove the default, it's going to complain to me about, oh, you didn't check all the cases. So I want to use the default, but I can't just do the empty. Could I just say like int x equals 1? Like it really doesn't matter. Let's try this. Failed to open file, no such file or directory. Okay. Where is failed to open file? fprintf s to standard error. %s file name. Let's see which file it could not open. Oh, and I really should be turning on logging. Goodbye world.parasitic.h. Interesting. Okay. Let me turn on logging. True. So we'll get more info. Opening file. I'd really like that to say which file we're opening. Opening file. Comp log. File name. Comp log. New line. Ugh. For some reason I put in a new line, but okay. Okay. Tests. Hello world. Parasitic.c. Opening file. Goodbye world.parasitic.h. Okay. So the problem here is that it forgot which directory we're in. So because these are in a subdirectory. Oh, and interestingly, yeah, this is working. So that's awesome. The one file did get compiled. Okay. So how do we solve this problem? See, these are like local files to this directory. These should be angle brackets. So I need to sort of check. Oh boy. So I need to be aware of where we are. All right. So we're calling parasi.exe, which is here. I'm not sure if you can see. Yeah, you can see the mouse cursor. Okay. We're calling it on something inside of the tests directory. So it ought to be able to remember that we're descending into the tests directory. Oh boy. So that means we need to like split these file names into paths. For the love of C split path. Split a file path into path and file. Yeah, this is split a file path. Okay. My goodness. Oh my goodness. Yeah, so really we ought to have like 3 functions. One function that takes a file name, splits it into the path leading up to the file name. One that gets the extension, one that just gets the file name itself. Like we should have all three of these functions. Is that what this is doing? I found have been using for years the two functions dir name and base name. Let's see. Dir name, base name. That's the directory name. I mean, that's good. Path this, the dir name is slash because that's a directory. USR, the dir name is dot. That makes a lot of sense. Okay, let's look at dir name and base name. libgen. Is that going to be portable though? Let's look this up on my website of choice, which is en.cpp reference. Base name. Are these... Those are Linux specific, aren't they? Uh-oh. C base name. Yeah, that's in Linux. How to write base name in C. I want to parse a string of a large length returning sample. Stir rchar with slash. Yeah, just find the last slash. And then this is tedious. And also on Windows, it could be not regular slash, it might be a backslash. Man, these are on POSIX, but I'm on Windows. Yeah, libgen.h is on POSIX. Stir token reversed. I do not want to understand stir token. I refuse. I liked this. Example. Maybe we just write like one function that, I don't know, returns Boolean, maybe even void, and just says split path. And you're going to pass in a path, and then you're going to get out a pointer to the directory, a pointer to the base name, and a pointer to the extension. Maybe? You know what? Let's not overcomplicate it. We're just going to make a function. It's so simple. It's simple. We just get the dir name from a path. That's all we need right now. Dir name. Okay. We're going to use stir rchar. Pass in a string. Path. Which character are we looking for? Good question. Greater symbol in standard C or C++. I just want like the slash on Unix and backslash on the other thing. Oh dear. Okay, so I could do that. I could do this. But that means I have to parse if-defs because I'm writing a compiler that can compile itself. I would have to teach it how to parse if-defs, and I don't want to do that. There's something in C++, but I'm not using C++. Ah, I can do this in my cheats file. We will copy this over. That's brilliant. We'll go to cheats.h and we'll paste this in. If we're on Windows 32, wait, Win32? I mean, I'm on like Win64, am I not? I mean, sure, this could be inline. You can do anything you want in cheats.h. All right. I'm going to call this path separator. Path separator. Please give me the path separator. All right. So if we're on Windows, it'll be backslash. All right. This will give us the position of the last path separator. Last sep. If last sep is null, we have an error. And I guess we just return the empty string. So the dir name, if there is no slash in this entire path, the directory name is nothing? Yeah, okay. Otherwise, we need to say int slash and after. I don't know what to call this. Do they have like good ideas for names for this? Put length temp input plus strlen last sep to do use strlen, I guess. I guess, alright, well here's like a really kind of a bad way to do it, but what we could do is we could say star last sep equals the null character. So I mean that mutates the path we got put in, that we just got. So should we like duplicate duplicate path then we search in dir for the path separator, and then this points to the last path separator. There, I'm being responsible here. Actually, I got to think about that more. So to do free dir question mark. Return dir. Okay. So this note, example, if you give it slash this slash that dot txt, it's going to give you slash this slash that. So it is not going to, it's going to remove this slash here. Okay. Why don't we test this out? Dir name of printf %s/n. Okay, stir_dupe is deprecated. Instead, use the ISO-C and C++ conformant name _stir_dupe. See online help for details. Let's look this up. Stir_dupe. Merged into ISO-C. Stir_dupe. Function is identical. This is in string.h. What's the problem? As all functions from dynamic memory TR, stir_dupe is only guaranteed to be available if standard C alloc lib is defined by the implementationer, and if the user defines want lib extension 2 to the integer. Okay. Stir_ndupe. Is this gonna be the same problem? Or the same, like, what is it? Why is this saying it's _stir_dupe? What is _stir_dupe? Why is it telling me to use _stir_dupe? Stir_dupe is deprecated. The POSIX name for this item is deprecated. In string.h, stir_dupe has explicitly been marked deprecated here. Undefined symbol, yeah, so it failed compilation. What? Huh? Does that mean that I need to pound define the thing that it's telling me to pound define? Do I really have to do the thing that it's telling me to do? Set this to 1. I don't want to. Please no. No, it still doesn't like it. Why is it saying use underscore? Instead, use the ISO-C and C++ conformant name _stir_dupe. And how come I can't find C _stir_dupe? docs.microsoft.com. Stack Overflow. Stir_dupe is perfectly correct POSIX function. It doesn't belong to the standard. MS guys decided to replace stirdup with underscore stirdup. I just continue using stirdup. It's unlikely the C committee will define stirdup to something else. Do not fret about any possible name collisions and just write stirdup for maximum portability. Okay, well maybe you can define CRT non-standard C no deprecate to disable this warning. Oh, I don't want to do that. Why don't I just, yeah, if it's a Windows specific, why don't I just go into my cheats file, cheats.h. We're going to do another one of these. And we will say, if you're on Windows, use stirdup. Pound define stirdup to underscore stirdup. And am I including string? No. String.h stirdup. So since I'm including cheats.h, this should be okay now. Yeah, okay. It did not print anything, which is concerning. This is a mess. Dir name, stirdup. Printf. Oh, I'm not using dir name anywhere, am I? Wait, yeah, I'm testing it, right? Dir name. Yeah. Oh, right. It's because I'm on Windows, so I have to use the Windows slash. Ah, yeah. Yeah, good. Yes, that works. Okay. Dir name works. All right. So where do I want to use dir name? At the project root, we want to say, make a character pointer called base directory, and that's equal to the dir name of project root. All right. Next, anytime you encounter, okay, so when we're in compile file, when we're doing this, we need to pass in the directory. No, it's not here. It's going to be when we're looking it up, when we're like opening the file, right? When we're opening the file. Compile project, compile file. Char pointer dir root, directory root. When we open a file, we need to prepend the directory root. This will allocate for me, right? No, it's gonna go. It needs to go into a buffer. It's tedious, tedious. Here's what we're gonna do. Fix this. Give me a buffer. We're going to allocate into this buffer. The size of the buffer is 1,000. Format is going to be %s, %c for the path separator, %s again for the file name. First we want the directory root, then we want the path separator on this operating system, and then we want the file name. In fact, this ought to be its own function. Function, character pointer, path join, given character pointer p1 and a character pointer p2. Return path. Directory root. This is going to be p1, and this is going to be p2. Then down here, we want path join dir root to file name. And then finally, our file name, when we are pushing the project root, we need to split off the file, the file name. So project root, instead of base name, or instead of dir name, I need base name, or in addition to dir name, I need base name. Function character pointer base name, character pointer path. If we're given this, we should expect poiu.txt. So simply find the last. This is going to be simpler. Last separator is here. We're going to increment, well, check to see if it's non-null. And if it is, then increment it, last sep ++, and then return last sep. So this is skip the slash, the path separator. All right. Base name. So where do I want to use this? I would like to use this right above here. No, right here. Project root. Delete that. Project root base name. Char pointer project root base name equals base name of project root. And that's what gets pushed in here. Okay. Let's test base name quickly. Base name of abc.txt. def %s /n column. Too few arguments to the function call. Right, so compile file now needs the dir root, project root. And where else are we calling compile file? Is that the only place? Okay, let's see if this works. c.txt, our test works, base name works. Let's see if we can compile the project. Failed opening file, hello world.parasitic. No such file or directory. Failed to open file. Tests hello world.parasitic / hello world.parasitic. What's going on? The file name ought to be just the base name, right? Let's print of file name. Oops, file name. This dir root equals this new line file name dir root. What exactly are we passing in? The file name is correct, and the directory is tests / hello world.parasitic. Tests / hello world. So that is not the directory root. That's the wrong directory root. So where are we using compile file? Project root. Compile project. Oh, right. So this should actually be project root is the file name. Yes, so this should be base dir. Ooh, looks like it may have worked. Opening output file. Let's see. Okay, so what do? We opened hello world. Opening an output file. Hello world.c. Hello world.c. Include goodbye world.h. Goodbye world. Opening goodbye world.parasitic.h. Reading to a string. Opening output file, and then just nothing happened? What's up with this? We're very close. Let's delete this. That's recycled in. Goodbye world.parasitic.h. Goodbye world.parasitic.h. Okay, so that's correct. Let's look over this one more time. Compile project. Project root. this is a file. So we get the base name of the project and the the directory name of the project and the base name of the project. Files to be processed. Push project root base name into the files to be processed. While we still have things to be processed, pop the first thing off. So this will give us project root base name. Compile that file in with the base dir, base directory, and then push the processed file. Push this file name into processed files. Then go through all the new files that we got and push them into files to be processed. These do not have the file name, or do not have a base directory in their paths. Okay, now we need to go to compile file. Opening a file. Yeah.
You still streaming?
Yeah, I'm close to ending.
Well, I'll probably come in after.
Okay. Remove Parasitic extension. Ah, this. Oh, it did work, but it put goodbye world.h up here, right? Because I forgot to. So it worked. It just put it in the wrong place. Delete this. Hello world.c is up there. Move to recycle bin. Oh yeah, it also put hello world.c up here. Move that to recycle bin as well. We're so close. Okay. So new file name is this. We should actually say path join directory root to the new file name, and then open it. Failed to open file, and we might as well print the file as well. All right, we only have our two uncompiled C files in here. Let's see if this works. All right, there's the compiled goodbye world. There is the compiled hello world. All right, looking pretty good. That worked. Let's commit this. I do not want to commit. Hang on. Remove everything. I do not want to commit this. Hello world.c or goodbye world.h. So it'd be nice if I could include like Parasitic compiled in the name. That way I could git ignore all of those. That'd be nice. Okay, so implement compile project. Does this still work even if I do that? Yes, it still works. Just delete this and this. I need you to go away. Delete. All right. Remove pound define. Sync those changes. Okay, we are ready to attempt to compile the compiler. Whew. All right, so how do we do this? Instead of, okay, we're gonna call, this is exciting. Make this bigger. Let's compile first. Let's compile first. Make sure it's compiled. Okay, we've got paracc.exe. We're now going to call paracc.exe on paracc.parac.c. So that is the root of the compiler project. If this works, it will create 1, 2, 3, 4 new files in this directory that are just .h or just .c files. Okay. All right, so I can't find no such file or directory / failed to open file. So should I do /? Is that going to throw other things off? Oh boy. Work needed in function parse item. Did it like do anything? Why is this telling me I have an error over here? What? No, it failed to even parse any of them. Work needed over here. Parse. Report an error. Oh yeah. So I have false parse constant expression over in paracc.c. I have this global, which is a Boolean, and I don't believe I taught it how to parse Booleans as constant expressions. So, yeah. Parse constant expression. If you get a literal int, literal string, literal open brace, or an identifier, constant expression. Another thing you could have is const bool. If you have, let's put this here. Bool, const bool. This is cool. Parse constant expression. We go here after int. Whoa, what just happened? Parse constant expression. Please go here. We're going to copy this. If you get a Boolean, true or false, parse true. If you can accept true or false, we're going to say bool value equals if the token arrow, if the, sorry, lexer arrow token token tag equals token true, then the value is true. Otherwise the value is false. We're going to say constant boolean and const underscore bool equals value. Okay, and then I just need to teach it how to print a const boolean. If expert as const bool is true, then we're going to print true. Else we're going to print false. All right. Let's try it again. Recompile, please. Okay, another parsing error. Expected close paren got angle bracket file name. I have no idea where this is. I believe it's in parasic.this. Expected close paren got an angle bracket file name. So it got like one of these. Yikes. It got one of these. It was expecting a close parenthesis. Close parenthesis. That is a weird parsing bug. I do not have, okay, here's what I should do. I should go into lex.paracc.h. I should go down to expect, lexer expect. And in here, where we're printing stuff, we should say, input equals %s and %.s, or we could just, let's print, I don't know, let's print the next 10 characters and then say ... Print the next 10 characters, 20 characters, and then new line. Lexer arrow input. Just tell me where we are in the input. Okay, recompile. And we'll try it again. Input is parse.h. Parse.h. What? Parse.h. I have parse.paracc.h. Is that what you're looking for? And then at to do, let's show me some more. Show me the next 50 characters. Recompile. Okay. Bug. It's like parsing a comment as what? Expected a close parenthesis? Huh? What? Am I missing a close parenthesis here? We're parsing the input. We're expecting a close paren. We're looking right here. Got an angle bracket file name. So somehow this is like triggering it to look like that's a Lexing bug, honestly. Okay, if that's a Lexing bug, then where did I comment out all that Lexing code? Let's print out all the tokens we're getting. Recompile. Try it again. This should be right after an exit. Oh boy. Read C stirred buff. Last sep, path separator. What am I looking for even? I should be looking for remove Parasitic extension. Remove Parasitic extension. This is equals remove Parasitic extension. Token FN. All included Parasitic file names. This is very near the top. In fact, it's so near the top that I ran out of wow, I need to be like logging this to a log file. Wow. Alright, I think I gotta call it for tonight. So, we're very close. We have, like, the build system in place. We're running into, like, parsing bugs, which, you know, these are complex programs. I have testing code for the parser already. You know, I've been testing it as I go. Just to prove to you, I will show my testing code. I believe every single expression type and type and statement and item, you know, has at least simple examples thrown at it. But somehow we're running into problems. Probably having to do with comments. Somehow some comments aren't being lexed correctly. I guess that would be my what I think is going on. So I think next time I'll get this working and then show you the bootstrapping process. So I thought we were going to get to bootstrapping. We almost did, but this is where I'm going to call it for tonight. So that's it. Take care. Bye.